All right, so here are my answers for part A for homework. I believe it was 2D, I think. So you can ignore that designation right there. So these are the ones from problems 589 from page 663. So I included some explanations here for these, but you didn't actually need to for things like 8 and 9. So your answer for number 8, it's fine if you just said right triangle, and for number 9, if you just said equilateral triangle, that's fine. So like I said, I just included here that in an equilateral triangle, the altitude and the angle bisectors are actually the same things. So let's take a look at the constructions that you had to do on page 671. So the first construction you needed to do was to construct an isosceles triangle using the CD as the base and then AB as the legs of your isosceles triangle. So as with all constructions where I have to build something, I'm going to start with a foundation on which to build. So I'm just going to draw a segment down here. Since this is going to be the base of my triangle, I need to make sure that my foundation is at least as long as segment CD. So then I'm going to copy segment CD onto that segment I just drew, onto my foundation. So I'm going to open up my compass here. I'm going to measure CD, and I'm going to then copy that here. So this right here is going to be the base of my isosceles triangle. And then to get the two sides of my isosceles triangle, I just need to copy side AB onto either end of that base. So for AB, I'm going to copy from this side. So all of the points along this arc right here are going to be the length of AB from the center of my circle, which is that end point here. And then I'm going to do the same thing from the other end point of that segment. So that point of intersection there is going to be the vertex of my isosceles triangle. So this will be the isosceles triangle that has CD as a base and AB as its legs. So some new terminology there too, by the way, if you're not familiar. This is referred to as the vertex angle of your isosceles triangle. These would be the base angles. This is the base, and these are the legs. So the two congruent sides are the legs. The base doesn't need to necessarily be on the bottom. You could have your isosceles triangle drawn this way as well, and this would still be the base, and these would still be the legs. All right, and then for the next construction, you're asked to construct a square whose sides are congruent to AB. So again, I'm going to construct something. So I'm going to go ahead and make a foundation on which I'm going to go ahead and build my square. So for this one, I need a segment that's at least as long as segment AB up here. So I'm going to then go ahead and copy the length of AB, which I think I already have here from the triangle I just did. So there are various ways you can construct a square. So one way is what we need is all four sides congruent to AB, and then we need 4 right angles as well. So I'm going to do it by constructing a right angle right here. So I'm going to extend this segment out a little bit, because what I want to do is to construct that perpendicular, I need to create a segment where this point is in the middle, and then I'm going to do the perpendicular bisector of that segment that I've created. So my first step is to just go ahead and create a segment where that point is in the middle. And then I can go ahead and do the perpendicular bisector of that segment. So I already have one point on my perpendicular bisector. Right? This midpoint right here is on my perpendicular bisector already. So I really just need one more point. So I have this point right here and this point right here, both on the perpendicular bisector. Right? Remember, a point is on the perpendicular bisector if it is the same distance from each endpoint of the segment. So here's one side of the square. So again, I'm going to draw that longer than it needs to be, and then I'm going to measure the length of AB onto that. So I'm going to then go up here, measure the length of segment AB, and then copy that length down here. So now I've got 2 sides of my square. So I actually have 3 vertices for my square. Now I need the fourth one. So what I'm going to do is I'm going to do the same thing here that I just did down here. So I'm going to go ahead and create the perpendicular through this point right here, perpendicular to that line, or that side. So again, I'm going to create a segment where that point is in the middle, and then find another point on the perpendicular bisector of that segment I just created, and then draw my side. And then again, I'm going to go ahead and measure off the length of AB here. So I'm going to measure the length of AB, and I'm going to measure that onto here. And now it's just a matter of, here's my fourth vertex, and then connecting these. So there's probably going to be some measurement issues, or some little bit of measurement error, I guess. So if your square clearly doesn't look like a square, if it's really wonky, just go back and check your construction and make sure that that you didn't completely mess something up. But if it should look pretty close, and then what I'm going to be looking at are the construction marks to verify that you did it correctly. All right, and then the last one you have to do is a circle whose diameter is the length of CD. So again, I'm going to build this foundation here on which to build. And what I want is, I want to measure the length of CD right there, because that's going to be the diameter of my circle. So I'm going to measure CD right here, and measure that off right here. And then to find the center of my circle, I need to bisect either this segment right here, or segment CD up here. It's really up to you. So I'm going to go ahead and just bisect the segment down here. So from either end point, I'm going to just locate the midpoint of that. So I'm going to do the construction marks as though I'm doing a perpendicular bisector. But what I'm really focusing on here is, where is the midpoint of that segment? So I'm not actually going to draw in the perpendicular bisector. I'm going to show the construction marks for the perpendicular bisector, because that's going to show me and show you how I got that point right there. So I can see that I use these 2 points of intersection to find that midpoint. And then my circle then is just going to be, the center of your circle is that midpoint, and then just go ahead here and draw in the circle. So feel free to just rotate the paper as well. Sometimes that's easier than trying to rotate the compass. But there is part G.